Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the starting material and reaction A. The starting material is C6H5, CH2, 5C is equal to O, Cl, which is 6-phenylhexanol chloride, a phenyl group connected by a 5-carbon chain to an acid chloride. Under Friedel-Crafts acylation conditions, UlCl3CH2, the acid chloride undergoes intramolecular Friedel-Crafts acylation. The chain has 6 carbons total between the phenyl ring and the carbonyl, 5CH2 groups plus C is equal to O, so cyclization occurs to form a 6-membered ring fused to the benzene ring, giving alpha-tetralone, 3,4-dihydronaphthalane 1,2-H1, also called beta-tetralone or more precisely 1-tetralone. The molecular formula of 1-tetralone is C10H10O. Wait, let me recount. C6H5, CH2, 5C, is equal to O, Cl, phenyl, C6H5, plus CH2, 5 plus C is equal to O plus Cl. In intramolecular Friedel-Crafts, the Cl leaves and the carbonyl carbon bonds to the ring. The product ring system, benzene fused with a 6-membered ring containing 1 C is equal to O. The product is alpha-tetralone, C10H10O. But the problem states A has formula C12H14O. Moving on to the next step. C6H5, CH2, 5C is equal to O. Cl means 6 phenyl carbons plus 5 CH2 plus 1 carbonyl C is equal to 12 carbons total in the organic part, with 1 O and the Cl leaving. So A is equal to C12H14O, megawatt check, 12C plus 14H plus 1O. The intramolecular acylation forms a 7-membered ring ketone fused to benzene, benzocycloheptane and benzosuberone, which is 6, 7, 8, 9 tetrahydro, 5H benzo, 7 annuline, 5-1 benzosuberone, C11H12O. Let me recount again. The acid chloride C6H5, CH2, 5COCl, the phenyl contributes 6C, the CH2, 5 contributes 5C, the COCl contributes 1C is equal to total 12C. Formula after losing HCl in cyclization, C12H14O. This forms a 7-membered ring. The carbonyl carbon plus 5CH2 plus the ipso carbon offering is equal to 7-membered ring fused to benzene. This is benzosuberone, 2, 3, 4, 5 tetrahydro, 1 benzoxpine. No. Actually it's alpha benzosuberone is equal to 6, 7, 8, 9 tetrahydrobenzocycloheptane, 5-1, C11H12O. Still off. Moving on to the next step. C6H5, CH2, 5COCl loses HCl on Friedel-Crafts. Carbons, 6, pH, plus 5, CH2, plus 1, Co, is equal to 12C, H, pH has 5H, CH2, 5 has 10H losing 1H from ring in FC is equal to 14H remaining. So A is equal to C12H14O confirmed. The ring formed includes 1 carbonyl C plus 5 CH2 plus 1 ring carbon is equal to 7-membered carbocyclic ring fused to benzene is equal to benzosuberone, correct, C11H12O for unsubstituted. But we have C12H14O meaning the fused bicycle is correct with 12 carbons, 6 in benzene ring shared, plus 5 CH2 plus Co is equal to the fused 7-membered ring gives total 12 carbons, 14 hydrogens, 1 oxygen. Product A is benzosuberone. And for the final step, KMnO4 under acidic hot conditions oxidize alkyl side chains on benzene rings to carboxylic acids and also cleaves the ring. In benzosuberone, the fused aliphatic ring contains a ketone. Hot acidic KMnO4 will oxidize the benzylic CH2 groups and the ketonadjacent CH2 groups. The oxidation of the alkyl substituted benzene ring with KMnO4H plus cleaves the aliphatic ring. The two benzylic carbons in benzosuberone, C5 and C9 positions adjacent to aromatic ring, get oxidized to CH2 groups, giving a benzene ring with two adjacent, ortho, CH2 groups is equal to phthalic acid, 1,2-benzenedicarboxylic acid. Oxidation of benzosuberone, a cyclic ketone fused to benzene, with hot KMnO4H3O plus cleaves the 7-membered ring at the benzylic positions and oxidize them, ultimately giving phthalic acid, benzene 1,2 dicarboxylic acid, which is option C. Benzene ring with two ortho, CH2H groups. A. Would require incomplete oxidation retaining the ketone and chain, not the product of vigorous KMnO4 oxidation. B. Benzoic acid would result from a monosubstituted benzene with one alkyl chain, but benzosuberone has two benzylic positions. D. Phthalic anhydride is the dehydration product of phthalic acid. The reaction conditions give the diacid, not the anhydride. Therefore, the correct answer is C. Therefore, the correct answer is option C.